which expression is equivalent to this polynomial, x squared plus 64? So it turns out that we really can factor something like x squared plus 64 if we use imaginary numbers. So we're used to doing x squared minus 64, the difference between two squares, but we can simplify x squared plus 64. So I'm going to switch over here to my notebook paper so that we can see the problem here. And at the very top of the paper I wrote down what the rule is. I cannot recall what the tutorial calls it. They have a name for this, and a squared plus b squared will factor to be a plus bi and a minus bi. So for example, on question 2 that I just had you see on the iPad, what happens is we can turn this into two parentheses, and the square root of x squared is x, and the square root of 64 is 8, but because this is a plus, we need to have an I. So minus 8i plus 8i, sorry, the program does plus 8i and then minus 8i. It does not make a difference if we do that. So if we take a look at another type of problem, 25x squared plus 1, it is also one of the practice problems. I know I'm not even showing it to you, but again, what we're doing is we're going to take the square root of 25, and the square root of 25 is 5. Take the square root of x squared. The square root of x squared is x. And then we can also do the same thing with the 1. The square root of 1 is 1. But then, because it's plus, this is going to be 1i. And then plus and minus. And again, if you write the minus first and the plus second, it won't make any difference. More than likely, the program writes this as 5x plus I and 5x minus I. They don't seem to like you typing in a 1 into the answer. So just, I will just alert you to that fact. There actually is one more like this in the practice problems, 9x squared plus 7. And we can start the same way. We can set up our two parentheses. The square root of 9 is 3. The square root of x squared is x. And it's a plus here in this problem, so we're going to have our plus and our minus. And in fact, it's going to be some term with I. And I know I did that a little bit differently than the previous two problems. But what happens is we need to figure out what times what equals 7. It was nice. 1 times 1 equals 1. 8 times 8 is 64. But something times something to equal 7, what it actually is, and this is just a long way, sorry about that, but the square root of 7 times the square root of 7 actually equals 7. If you want to get technical here, 7 times 7 is 49, and then the square root of 49 is 7. So what we're putting in, because we need to take the square root of 7, just like we took the square root of 64, or we took the square root of 1, this time we're going to take the square root of 7, and the square root of 7. To get our answer, I'm just going to write one more. I like it a little bit better, and I'm not sure how the program likes it, but I prefer the I in front of the square root.